Imagine a place on Earth more alien than Mars, the Mariana Trench, the planet's deepest scar. Here, crushing darkness and unimaginable pressure rule. Now, picture detonating the most powerful weapon ever made at the trench's bottom. Would the Earth split? Would a wave swallow continents? Let's find out. This isn't just a wild fantasy, it's a journey into the heart of physics and the power of our oceans. The Mariana Trench is one of Earth's last frontiers, shrouded in mystery and extreme conditions. Our thought experiment pits human ambition against nature's might. We'll travel nearly 7 miles down, armed with a device that can create a temporary star. What happens when a nuclear fireball meets the cold, crushing Pacific? We'll separate fact from fiction, science from spectacle. The answer isn't just about a big boom, it's about the resilience of our planet and the wisdom of leaving some places undisturbed. Let's begin our descent. The Mariana Trench is more than a deep hole. It's a geological marvel. Located in the western Pacific, it stretches over 1,500 miles, plunging nearly 11,000 meters down. If Mount Everest sat at its bottom, its peak would still be a mile underwater. Down here, sunlight vanishes, temperatures hover just above freezing, and pressure is over 1,000 times that at sea level. This pressure would crush a submarine like a soda can. Life here is rare and bizarre. Tiny, gelatinous creatures built to survive the squeeze. These pressure-loving organisms thrive where almost nothing else can. The trench is a unique, ancient ecosystem stable for millions of years. Detonating a bomb here isn't just a physics experiment, it's an assault on a world unto itself. This is the arena for our cosmic experiment. Our tool of destruction? The Tsar Bomba, the most powerful nuclear device ever built. Tested in 1961, its 50 megaton blast was over 3,000 times stronger than Hiroshima. Its fireball spanned 5 miles and the shockwave circled the Earth 3 times. For a moment, it was a man-made sun. The original design was for 100 megatons, but it was scaled down to limit fallout. This bomb, designed to flatten cities, is now headed for the ocean's deepest point. Its power comes from nuclear fusion, the same process that fuels the sun. A fission explosion triggers fusion, releasing unimaginable energy. The Tsar Bomba is the apex of human destructive capability. Dropping it into the Mariana Trench is the ultimate clash: human technology versus nature's fortress. Let's see what happens next. The scenario begins. A reinforced sphere carries the Tsar Bomba down into the abyss. Released above Challenger Deep, it begins its slow, silent descent. Sunlight fades, temperatures drop, and pressure mounts relentlessly. The bomb passes through layers teeming with strange, unseen life. The descent takes hours, through a world of perpetual midnight. The casing, an alien intruder, finally settles on the silty seafloor. Here, the pressure is over 16,000 pounds per square inch, and the darkness is absolute. The bomb rests in a place visited by humans only a handful of times. The countdown begins. The stage is set. The deepest, coldest, most isolated place on Earth. The world holds its breath. The timer ticks down. The moment of truth arrives. 0 hour. The Tsar Bomba detonates. For a split second, a star is born 7 miles beneath the sea. A fireball millions of degrees hot vaporizes water, creating a vast radioactive steam bubble. The bubble expands rapidly, nearly a kilometer wide, before the crushing ocean pressure fights back. The steam bubble oscillates, expanding and collapsing in a violent dance. A shockwave rips through the water, obliterating all life nearby and echoing across the globe. But water absorbs and scatters the energy. The shockwave weakens as it travels. The explosion carves a crater in the seafloor, vaporizing rock and sediment, but it won't crack tectonic plates. The Earth's crust is far too strong. Earthquakes and volcanoes release far more energy than even this bomb. The result, a scar on the seabed, not a planet-shattering event. The ocean contains the blast. Would this explosion trigger a mega-tsunami? Science says no. Tsunamis require massive vertical movement of the seafloor, usually from earthquakes, not explosions. A nuclear blast creates a localized bubble, not a column of water rising to the surface. Most energy is absorbed or dispersed by the ocean's depth. At the surface, you'd see a turbulent swell, not a towering wave. The ocean acts as a shock absorber, diffusing the blast's force. Only a massive landslide or earthquake could trigger a true mega-tsunami, and that's highly unlikely here. The bomb's energy is tiny compared to the forces locking tectonic plates together. The trench's depth is its greatest defense. The nightmare of a world-destroying wave remains fiction. The real danger isn't a cracked planet or drowned cities, it's radioactive contamination. The explosion vaporizes water, rock, and sediment, creating a toxic radioactive plume. This plume would be swept into deep ocean currents, slowly spreading around the globe. Over time, radioactive isotopes would enter the marine food web, concentrating up the chain. The unique life forms of the trench would be the first victims, an entire ecosystem erased. Survivors of the blast would be poisoned by lingering radiation. We'd lose a world we barely understand, and the scientific loss would be incalculable. The deep ocean is a vital part of Earth's life support system. An injury here can have unforeseen consequences elsewhere. Nuking the trench is an act of cosmic vandalism, a profound misunderstanding of power and responsibility. The question isn't can we do it, but why would we? The deep ocean deserves our respect, curiosity, and protection. Some frontiers are best left undisturbed.